In this demo, we're going to show you how to create Logical Volume Management Disk (LVM). Login as root to your systems. We assume you have added in a 200 MB SCSI disk to your virtual machines. To check whether if the virtual machine recognizes the disk, you can do the command fdisk -L. You have a ID hard disk HDA, a SCSI disk, which is the first SCSI disk SDA, and we have the second SCSI disk FDB, which is 200 MB. The current does not have any partition information. We will partition SDB, the second SCSI hard disk that we just added in. Do fdisk /dev SDB. M for help. P to print the current partition table, which is empty currently. We will create 3 primary partition disks on SDB. Do N for new partition, P for primary partition, and key in 1 for the first partition. This hard disk has start from cylinder 1 all the way to 204. You start at cylinder 1 and we'll create a 20 MB partition. Press P to check if the partition is being registered. You can see that SDB1 is the first partition that we have created. You carry on to create the 2 partitions. P for the second partition, 2 for the second partition, and we will start at default 21 because the first partition ends at cylinder 20, so the next partition should start at cylinder 21. Again, we key in 20 MB for the second partition. Press P to print the partition table again. You can see the SDB2 is being created. We'll create the last partition. Again, we select P for the primary partition and 3 for the third partition that we're going to create. It start at cylinder 41 because the second partition stopped at cylinder 40. Again, we key in 20 MB. You can press P for help. Apologies, P to print the partition table. As you can see, we have created 3 partition tables. Now you notice the partition system ID is Linux. We need to change to Linux LVM. Press M for help. To change or toggle the system ID, we use T to toggle the partition ID. And which partition ID that we want to toggle, we toggle the first partition. You can press L to list down what the partition ID that you can toggle to. We use 8E for Linux LVM. You can press P and you notice that the first partition now is being changed to Linux LVM. We'll do the same thing for the other 2 partitions. Press T to toggle second partition, and since we know the code, we don't have to list anymore. We can straight press 8E for Linux LVM. Again, we'll toggle the third partition, 8E, and we can print to check that all the 3 partitions now is Linux LVM partitions. Press M. To save the partition information to the hard disk permanently, we have to press W to write the table to the disk and exit. When you finish, remember to do partition probe, which is part probe, so the kernel will reread the partition table that is newly added. You do not have to worry about these warning messages. Okay, let's do a clear screen. To check again, we can do fthis minus L, and you notice that SDB now has partition information. If you just want to check for SDB partition information, you can do fthis minus L slash dev SDB, the second SCSI hard disk, and we have the 3 partition in SDB. We will use these 3 partitions to create our volume groups and logical volumes. We will treat this individual partition like a different disk. Let's do a clear screen. You can do LVM command and press enter. You'll be brought into the LVM utility prompt. You can press help to see what the LVM command available to you. Now you don't have to issue the command within the LVM utilities. You can actually exit from the LVM utilities and then use the utilities like pv create within the command prompt. Okay, let's create the pv disk using pv create. We have 3 partitions just now. You treat them like individual disks. SDB2 / DV / SDB3. We have successfully converted the 3 partitions into PV disks. You can type PVS to check that the partitions or the PV disks are being created. As you can see, SDB1 to 3 is now a PV disk. SDA2 is your operating system disk. We will continue to create the volume group using one of the PV disks, SDB1. You can do that by doing VG create the volume group name. We call it my VG, and using the first PV disk, which is DV SDB1. Press enter, and the volume group now is successfully created. To check, you can do VGS, the volume group scan. You press enter, you notice there is my VG that was being created. Volume group 00 is actually your operating system volume group. To check just my VG, you can do VGS my VG. From the result, you can see that the number of PV disks used to create my VG is 1. There is currently no logical volume created inside my VG, and the VG size is 60 MB in total, and currently there's free 60 MB. Now let's try to create a logical volume inside my VG. To create a logical volume, you can do LV create minus capital L, which is the length of the logical volume 8 MB, minus small letter n, which is the logical volume name. We call it my LV, and is to be created inside my VG. You press enter. You can ignore these error messages or warning messages. You can see that logical volume my LV is created. You can check by doing logical volume scan, LVS. You can see that my LV is being created inside my VG. logical volume 00 to 03 are actually your operating system logical volume that was being created during installation time. You can do LVS just on my VG. Now you can see that my LV actually is residing in my VG, and the logical volume size is 8 MB as we have previously specified. If you like a more detailed result of the VG, you can do a VG display -V for verbose on my VG. Pipe to more, so you can see that my VG details of my VG will be displayed. Right, the VG size is 60 MB, currently free 8 MB, and within my VG there's a logical volume called my VG, sorry, my LV, and the size of the LV is 8 MB, and my VG is made up of currently DVSDB1. Now let's try to format my LV so that we can make use of it as a file system. You can do mkfs.ext3, which is to make file system of type ext3, on /dv myvg/myLV. This will basically format the my LV logical volume inside my VG. Let's create a mount point for this logical volume by making an empty directory. Do mkdir/myLV. We'll mount the logical volume /dev myvg myLV onto the directory just created called /myLV. If we do a df -h, you should see that my LV is currently mounted. It's 7.8 MB in size, and current available space is 16.3 MB. You also can do a mount command. You can see on the last line that this my LV partition or logical volume is mounted on my LV directory. The file system type is ext3 and is read writable. You can see that my LV is currently mounted. To unmount it, you can do a umount on the directory itself, my LV. If we do df -h again, it should be gone. Now if you want my LV to be automatically mounted each time the system rebooted, you need to edit the etc fstab file. Before we edit, it's always good to make a backup of the current etc fstab file. Yes. So we'll do nano -c /etc fstab. This file will always be read by the system each time the system reboots. The system will check what is to be mounted automatically inside this file. So we want my LV to be mounted automatically each time reboot. We have to specify inside here dv/myvg/myLV, and needs to be mounted on the directory called myLV, and the file system type is ext3, default mounted as read writable. Priority to check is 1 space 2. Once you're satisfied, you can do a save by doing Ctrl X, say yes, and press enter to write to etc file. You can issue the command mul -a, which will read the etc file and mount the file system inside. If you don't receive any error message, it's good. Do a df-h. Now you can see that my LV is mounted again, and the size of my LV is 7.8 megabyte. Usage is currently available 6.3 megabyte. This will end our demo.